to give you a introduction to the different types of projects that we do or that we discuss in the cluster. We will go through our active research projects that we have. First, forming projects and then joining projects. Okay, let's go. This will be quick. We have 12 different projects that we'll try to go through here in let's say 12 minutes or so.
Yeah, so an overview.
Yeah, and the point is just to show you what we're working with and who is the contact person for each project that you can contact and discuss further with. And of course, these slides will be available after the conference, so you can look at the details and so afterwards. Okay? Nu kan du byta bilden igen.
Yes.
Du byter.
So I will change the slide.
Okay, I will talk about these six projects in forming. Okay. First, we have Klimal. It's a 3-year project that started in the fall. It's led by Jönköping University. The objective is to enable recycling of aluminium for high performance applications, especially for rolled products, not cast aluminium. Okay. And because some applications require sheet solutions, I mean, a lot of recycled aluminium is already used for cast applications, but not for sheet applications. Okay. And the project really dives into trying to develop understanding of how trace elements in these recycled alloys affect formability. So how can they be rolled into high quality sheet material? And then how is this sheet material, how does it work in production? Because the formability is negatively affected by these trace elements from the recycling. Oh. Okay, next project. Thermlight 2. We are also in the start phase. We started also in the fall. I'm saying we because I'm the project manager for this. And the objective here is that we try to develop an induction heating system for sheet metal forming applications. And we focus, in this case, press hardening or hot stamping of boron steel sheet. And the objective or the overall aim is to reduce the energy use and replace fossil gas burning furnaces. In Sweden or in this part of the world, many furnaces are already electric, but they're not using induction. They're using radiation or convection heating. But so we think that with induction we can make this more efficient. But in a lot of places in the world, the furnaces are fueled by fossil gas. So we can replace also that with induction. Okay. So we have done a pre-study in just checking that this works. And now in this project, we try to develop this into a complete working heating system with a control system and also prediction of the heat distribution so we can optimize that. So project FUBI. It's a 3-year project as well. We're now in the middle of it. It's led by Rice, one of my colleagues. And here they want to develop simulations for high-speed forming of very thin sheet metal for, what's it called? Fuel cells. So they are really looking into material characterization and to make sure that the characteristics that we measure and also the setup that is used for testing is really corresponding to the real world situation, because this process is very quick in the industrial environment. So it's difficult to get a good test setup that is easy to understand and model. Okay. Then we have a project called SafeBut. It's a 3-year project that actually just ended. Right? Yes. Look at Yvonne because she was involved in that. A few more days. Okay. It is a collaboration project between Sweden and Germany. And it's the development of a battery box concept with a lot of integrated functions. and it's made of a special material with, I think, aluminum foam and so on. And the point is to get better crash performance in these battery boxes, and also, of course, include all these functions. And as I understand, there's still some challenges with the molding process and get everything to be predictable and working well. Okay.
Mm-hmm.
Then we have a project called ISTAT. It's a 2.5-year project. We're in the middle of it, and it's a collaboration between Sweden and Spain. It's within the Eureka Smart program. Here, it's about the stamping process and trying to get high quality products and an active control of the drawing of the sheet metal. So it's sensors and actuators adjusting the holding of the sheet to get a good quality part. And so it's continuously adapting the process. And we're sort of in the middle of the project, and the sensors have been tested, and the actuators have been developed, and the control system is under development. So real experimental trials with the complete system will, I think, start pretty soon. Okay. Then I think the last project. I think we're quick, aren't we?
We're quite good.
Perfect. So this project is a 3-year project as well, and we're in the last year. It's going to end, I think, in the end of this year. It's led by Blekinge Institute of Technology. And here it's about getting better simulation models for increasing the accuracy of prediction of failure in the sheet forming process. And also, based on that, prediction of how to adjust the process to avoid the failure. And there are a lot of different things that are evaluated and developed here, both experimental work and also a lot of modeling work and material characterization and so on. So a lot of both numerical and experimental work that's going on. Okay.
Right.
I think I'm done.
That was an overview of the forming project. Should we let in a few questions on the forming projects before we go into the joining, or should we take every questions in the end? What do you think, Johan?
I think we do everything in the end. So
everything in the end. So please save your questions, remember them, and we go slightly into the joining. We have also 6 projects that we would like to mention in joining. We have grouped them under if they are addressing circularity, e-mobility, or digitalization, as we did with the forming projects. Ideal, Pia Borg is project lead, however, not here, she's in another, she's in the component cluster, yeah. So basically, it's about getting resistance spot welding, which is a very common method into the production with steel car bodies, to work also for aluminium. There are a lot of problems in aluminium spot welding. This project has started fairly recently and will go on until mid-2025. And it's about avoiding cracking, avoiding clogging of aluminium onto the equipment, understanding how modern equipment and smart measures in the welding process and procedures can help to get up the weldability of aluminium, cast aluminium and sheet. So you have problems with cracking, porosity. There are a lot of discussions on surfaces and times after certain treatments and so on. So it's how far can we get by smart process adaptation project. Midwest is a project that is finishing now in November, December, and this year. And there, the idea has been to mechanize improvement methods for welds. TIG remelting of the transition of the weld, where it goes onto the base plate, is a known method. But now we can scan with a laser scanner and find exactly where to treat. The precision needed for the treatment is plus minus half a millimeter. We can get it down to 1/10 of a millimeter with laser scanning and adapted robot path. And the same goes for this high frequency mechanical impact. It's a very interesting method that can give 5 times or 10 times, almost 8, I think, of the earlier life in fatigue of the weld. But since we have been working for long with getting vibrating tools out of our workshops, we don't want to get them in again. So it should be robotized. And also, of course, local machining, burr grinding of the transition is another method. We have actually succeeded in mechanizing TIG and HFMI, high frequency mechanical impact. And we have so far proof of concept on this one. We need a little more sturdy treatment equipment, but we have the robot path following on that method. So it's a successful project, and we hope also that ABB can be able to deliver this version of the robot system. Then we have Paul Jonasson here, that is project leader for this pre-study, and it's finished now, I think, and you are searching for partners for the continuous project. You have success. It's about secondary aluminium and also without heat treatment for cost applications. And it can save a lot of CO2 and, of course, money if it is successful. So it's really a materials development project. And Paul can tell you more about it. And also, if you're interested, contact him because he's seeking more partners for the bigger project that's coming now. Commit is a project in the electric vehicles area. How do we know that these thin junctions between mixed materials are working as intended? It's copper to aluminum or similar. And how do we know that these battery vehicles will not burn or fail? We need new methods to evaluate these joints. And that is what Commit is about. It's about measuring the contact resistance. It's about predicting the fatigue in time of these joints. And David Löfgren, who's sitting here, is project leader together with Tage Hammar. So if you have any questions, please contact David. Yeah, some images that I have to skip more or less. I have hopefully mentioned some of it, David. But there are a lot of issues with these joints, of course. Well, VC is a project financed by Production 2030 and Vinnova. It's about visualizing how the welding is going for the welder. We have digital welding training systems for welders today. So you can get the first weeks via a computer, and the welding gun is a plastic. And the weldment is also plastic, but it's barcodes, so it looks like steel when you look in a screen. But you don't have any aid for the manual welder. And we want to sensorize the robot or the welding gun and get feedback into the helmet. So the welder actually knows if he or she is going according to plan, according to the procedure specification or not. And he or she will get hints. Please go faster, please change angle, please do something better. And we are in the early phase of the project right now. We are creating these sensors. We have RISE building those. We are also looking at how to cleverly inform the welder, not over-inform. And we have Mion looking at that. So it's a very interesting project, and it's too early to say how it's going, but so far so good. And last but not least, we have MadBond, modeling of adhesive bonding for multi-material design. It is a simulation project where we want to be able to predict how a mixed material joint made with, for instance, adhesives and mechanical joining will perform when it comes to deformation and eventual risk for cracking or other damage. And David Leverborn and Mohammad Rudi in RISE are project leaders, and we still have some months running of the project. A guideline will be developed, and we have been able to predict deformations, and there's more work to be done with a damage indication criteria, and also, of course, to get the guideline developed and out there. So that is an overview of these projects in joining. It's not all the projects running, but they are the ones that we had the chance to deliver to you in 20 minutes.
Yeah, I think we made it in time, actually.
More or less on time. Yeah.
So, of course, there are lot of more things to say about all of these projects.
Yeah.
And you can ask questions to us now, or if there's some of the people involved are also present. And also, of course, you can contact the contact persons afterwards. But please, we're open for questions.
Yeah, we have 10 minutes now before we are letting Yvonne up with the next project presentation. It will follow two full presentations, normal presentations, and not only the overviews.
Maybe I should just mention a complimentary.
That's fine.
The Alicante project is a project that is intended to use secondary alloys, cast alloys, for structural applications. The challenge there of the breaking effect of purity, like iron and so on. And there's also an intent to try to develop high-strength alloys without X-ray treatment. So there is a benefit in carbon in both these areas, of course. And the reason why we do this is because current alloys are not intended initially for structural casting, but we foresee in the automotive and other industry in the coming future. So there is a need for new material. And also, finally, the project is now, as Joakim said, is coming, the pre-study is coming to an end. We're looking for, in a half year or so, to start an industrial evaluation phase, where we can have a larger consortium and do more industrial validation. So that's basically the complementation of this. I said there are some challenges in the material development, but I think we will try to find a solution there. Okay.
Great.
Thank you, Paul.
So more questions?
So, comments, questions, Mats?
The choice of joining method can both increase and decrease the possibilities to reuse and recycle materials and components. Do you see a lot of demands in this direction?
Absolutely, absolutely. Demountable, invisible joints has been a request sometimes, and demountables are also such, of course. If you brace and not weld, it's easier to via heat to let the joint go. Some adhesives could probably be made to let go with some extra treatment, light heat or something else. Welds, good luck. We need to cut it.
Yeah, but there are, I mean, there are initiatives in this direction. I know there's a joint, I think it's joint between us and others, of course, application or proposal in right now without we don't know the response yet in FFE, right?
Right.
For demountable joints in battery boxes, I think.
Yeah. So exactly. Yeah. In that area, we want to look at the battery box as a technical system. How can we improve it? And we want to recycle it. So therefore, we need to open it and refurbish it. And right now, we don't know how to do it, but we will try to do it. Yeah. More comments, questions?
Together with that, so where do you see the future of joining going? Is it towards this recycling and circularity, or are there other sort of more?
It's a very good question, Yvonne. I wish I had a perfect answer, because then I would know where to go. You know, we made an application a few years back called SING, Sustainability Index for Joining Processes, where we wanted to rank the joining processes regarding their sustainability. But it was not granted by Vinnova. It was a pre-study application. And their comment was, it's only joining processes, and we don't foresee that it's scalable enough. So apparently we did not manage in telling the whole story of what could be possible to do. I still think that that track is interesting. I still think we should do something there. We need to, okay, it's the materials development phase and the end user phase that are the big influencers on CO2 footprint, but still we don't want the production to be dirty. We don't want it to be made in a bad way. So we should also look at that, of course. So I think we should do what we can in this perspective. We had a very nice presentation from AstraZeneca in the black box room. And it was a comment that the processes we are implementing today will be still there probably when we are judged upon how sustainable we are. And depending on what goals we have set and what EU has set for us, it's somewhere between 2030 and 2045. So that means that now we need to select our processes for it. So it's here we need to work.
I think also in general, it's an interesting compromise between, some of the projects you presented are about joining different materials that are difficult to join.
Yeah.
But maybe they are also difficult to demount from each other and also maybe recycle if they are together and so on.
Yeah.
So it's the one on one hand you want to optimize each material for each application, each part of the car or the product, but maybe there's compromise there with being able to recycle this. Maybe it would be easier to make everything of the same material.
Yeah.
Then it would be easier to recycle it, but of course you would have other drawbacks with that. So it's a compromise in some way. So yeah, you need to evaluate or make a judgment of these things together.
Yeah, and not only initial cost. We need to look at the more total cost and full life perspective. How do we find models for that? How do we find driving forces to go towards that? The question is much larger than choosing the material or choosing the joining method. It's related to who owns the product, who's going to recycle it, who is to benefit from that profit. So it's a very big question. Yeah, but you actually do get some help because the truck companies are now discussing selling millions of transport kilometers instead of a truck. Yeah. Mm-hmm. So in that perspective, they will be interested in building the trucks that are extra sustainable and don't break. So I think we may have some help there. Yeah, more comments, questions? No, then we have 5 minutes to change speaker. Perfect. Perfect. We take a short break and thank you. Thank you very much. So we have the next presentation coming up. Det gick ju snabbt. Det gick ju ovanligt snabbt. Det gjorde det. Med någon minut till godo. Ja, faktiskt.